that owns IoT. There's lots of different value chains out there. There's lots of different use cases and lots of business that needs the value capturing and people that have different products, different solutions, different services that they offer as part of that. So one of the things I mentioned last time, we've set up a network of IoT ignition labs, and one of those is in sunny Swindon, for anybody that's ever over that way. And the goal there is to actually work with partners, whether they're big or small, and then actually pull together the services and the scaling partners so that people that have something that's really good in the industry, particularly in software and services, have somewhere that they can take that business and actually scale that through, whether it's a telco, whether it's a systems integrator. And it's been an interesting journey. We opened the lab in Swindon at the end of June. We've got 5 others around Europe, and it's become a great success and a global entity now. We're looking at where else we open them. And part of the success is actually that bringing together of the partnerships. So what I wanted to do was introduce Jerry Hodgson. And Jerry is one of our innovators and the first one that we took through the Swindon lab, and so that he could share his experience on how to work with the big guys and girls in industry and what it is that you need to do to be successful in doing that. So Jerry, would you like to come up?
Yes, thanks very much, Karen. What's been really exciting about meeting Karen is when we started to put together our technologies about 5 years ago, and very briefly talk to you about that, which was based on the Zigbee platform. What we wanted to do was to find a way that we could support the elder care. That's primarily the product that we're looking at, elder care support of people with learning difficulties. And we based it on a Zigbee platform. Very early days, I don't think any of us had heard about IoT at that time. But what we needed to be able to do is to put together some sensors that would stream data via a gateway back up to the cloud. And that all seemed very simple to us. And as we looked at the way that technology needed to work, we needed to have intelligence out on the edge, out in people's homes, being able to make decisions and send alerts. And so this is what we have here on the backdrop for you. This is running in one of the homes that we support. We have live feeds coming through with various sensors that are in the home, looking at where this person, here we've got the bed, living room, movement around the home through the hallways, fridge access, various other items that from an elder care point of view, we need to be able to identify issues that are coming through in behavior. If somebody has something like a urinary tract infection, especially the men amongst us, we're not going to go and see a doctor too readily. We'll hope it goes away. And so what's very important is that we identify trends within the home and then be able to to alert the family or carers to any issues that might be coming through. Now, in order for this to happen, we needed a fairly intelligent technology that was out in the home, being able to collect data and interrogate that information, make decisions. Also streaming the data up to the cloud. And when I met with Karen, what she talked to us about was the fact that the type of technology that we have here for Intel, it was the ability to have devices out in the home, possibly wearables, which I guess some of you in here probably got Fitbit or something like that, where you're looking at your, where you're looking at the movement, the behavior. There are other devices in terms of taking medicines, ingestibles, and Intel are working on some very advanced technologies. That starts right out there with the patient. We're collecting this data, and we needed to send it back through the edge up to the cloud. Again, another device that Intel were working on at that time, being able to bring an IoT gateway, and that we adopted. And I'll just speak a moment about the work that we did. But of course, once we get the data into the cloud, and large volumes of data is what we're interested in, using, again, Intel-based platforms, hosted data centers to be able to aggregate that information and look for trends. And so when Karen was saying a little bit earlier about what does a small innovator, if you want to engage with large businesses, what is it that you have that makes it interesting for them as well? This is not just about Intel opening doors for us. What we needed to be able to do was to demonstrate, both in terms of the way we run the business, the structures we have, the staffing, the way we've gone about looking at investment in the company, making sure that those elements are in place. If you have software development, the assumption is from large companies that you will already know how to do that. When you engage with the bigger organizations, what Intel wanted to see was that end-to-end solution. How do we use Intel platform all the way through and help small companies work with much, much larger organizations to bring the devices out into the market? And so Karen, we've been very fortunate that she's worked with us as a mentor to us within the business to look at the whole process of revenue generation. Where is it that each element in that supply chain, where will other companies that we work with actually make money? And it's not just about revenues for us. If we're going to partner with other large system integrators, there must be some level of service that they can layer on their business as well. And so for all of you, as you look to expand your companies and you look to work with other organizations, we've certainly found this over the last few years that partnerships are extremely important to us. That's the way that we're able to scale to, I just wonder if they're going to, I was getting a signal there to call time. But that's the way that we've certainly worked with other organizations. How is there a partnership where there's both benefits to Intel? And when Karen opened the IoT lab, what she was looking for was small companies, and I know there's been several that you've worked with, that are able to bring their technologies to the lab, work with some incredibly bright people. Some of the issues we had porting onto the Moon Island Wind River stack, they were able to call in brains from Russia and through into Europe to help with that problem. And that was an incredible experience for us, that there's people out there on tap pretty much to pick up the challenges we had. But the quid pro quo for that, for Intel, was to be able to see the potential growth for small businesses. I mean, what we're looking at here with eldercare is, it's been well documented in the press and recently when you look at hospitals, the overcrowding that we're getting, especially within A&E. And that you can scale that across the whole of the Northern Hemisphere here through Europe and North America, where there's some massive issues with the growing elder population. And that excites the big companies. What is the ability to scale this beyond maybe hundreds or thousands of units that we might have thought of when we first were developing the product? And now as we've met more and more scaling partners through Intel, the opportunity to literally sell millions of devices. And of course, that's where the big companies become interested in those types of technologies. So Karen, is there anything that you would like to add to that? Thank you.
So what we're looking for is something that's of mutual benefit. So if you want a sustainable business model, you have to have something that you're going to give, and you have to understand what it is that you want to get. And that sounds really simple, but it's amazing when we do. I have this really, really large whiteboard in the Ignition Lab, and we start with, how are you going to go to market? What's your product? What's your value proposition? And what is it that you do? And who are the partners that you're working with? And what is it that they do? And then how do you all make money? Because that's it at the end of the day. But you have to start with what value are you creating and who are you creating that value for? And often, and I say this, I've worked for Intel for 22 years. I'm technology 3, cut me, I'm blue inside, Intel blue, obviously. There may be a bong if you cut me as well. But what you really have to think about is what value are you creating and who are you creating that value for, not what technology you have. And all the gateways, doesn't matter. I absolutely love my ARM friends, B&B are based on ARM. There is business out there in IoT for everybody, and there's space for everybody. But if you want to win a bigger slice of that space, you have to really think about that value that you're creating and what your USP is. Why are you different? Why would a big company want to work with you? What is it that you offer them? And then what other partners would there be? So we worked with a bunch of gateway companies, and we work with, I can see him from Eurotech over here. And we work with Advantech, and we work with a bunch of companies that make gateways. And it's up to the customer to choose which product they want to buy and who they're going to work with. And then there's got to be a scaling opportunity for them. Why would they want to work with a smaller company? But again, if you start at that value chain and you think about who you're creating value for, it may be that somebody else has an in with the medical market. One of the telco providers that's interested in this product is based in Germany, and they already have a contract for over 1 million households for providing this kind of healthcare in, and it's all analog based, and they need to change it. And they came to us and said, we think we're going to have to start from scratch and create this. And luckily for me, one of the health life science guys said, we've got somebody that's been working with an innovator on that. And then all of a sudden they said, fantastic, we don't need to create our own. Can you introduce this? And how do we license that product? So that's part of it, is the understanding what is it that you're doing. In this particular instance of healthcare in the home and helping people stay in their homes for longer, you're providing value to a bunch of people. So you're providing value to the individual. Most people don't want to go into a home for the later stages of their life. They actually want to be in their own surroundings. You're providing value for the family. The family feels a lot more comfortable that they know that mum got up this morning. You're providing value back to the health services. So this data could be shared with a bunch of social workers, GPs, people that actually can look at the data and use that data. You can actually save money for those companies. You can provide value to the care companies that are looking after people. Provide value back to the government in understanding what happens later on in life, so research back in. You're providing value by enabling people to stay in their communities for longer. If you're lucky enough to live in that kind of community, actually staying in that community is really important for people, and you probably have a lot of value to still add, even though you might struggle with some of the things that you need to do at home, like make your supper. So that's it. When you're thinking about your value chain, you actually have to know who it is that you're creating value for and why somebody would want your service. And that's typically not about technology. That's about the service that you're creating. So I hope we've just given you a little bit of an insight into how it is working with the big guys and what you can do. It's been a great experience for us working with a smaller company. And I do a lot of level 39 in London with small companies. I mentor companies up there. So when people say to you, the big guys aren't interested, it's not true, but you just have to know what it is that you're looking to do to come and add value and create that value for your customers. Okay? Thank you very much.
Thank you, Jerry. Thank you, Karen. Right, next up. Let me get it going. We have James from FlexEye.
Good evening. James Davies from FlexEye, and I really can't remember the last time I used a stick mic like this, let alone balance it with a clicker, so hopefully I'll do okay. Thanks, Duncan, for inviting us to talk tonight. And I'm time-boxed with 15 minutes, so I just really want to run you through a magical path of games, cats, cities, and ice, which are somewhat connected. So you might be asking yourself, what's the common thread between the games industry, large cats, cities, and ice? And the answer with that starts in the first place with the fact that FlexEye, which is a small company based primarily in Guildford, is a technology company, and it's inspired from the games industry. So if you go back about 20, 25 years, some of the premier game studios at the time came up with the concept of an engine, and they came up with the concept of a console, and the idea was that they licensed the engine to companies who would use the console to build applications, and FlexEye took the same approach. So even though our roots were in operational intelligence, historically we've done a lot of different types of projects, ranging from projects with British Petroleum, BT, some in the financial sector, so really quite a disparate array of projects. And that's the tie into the games in terms of our engine. The FlexEye engine is inspired from the games industry. The other core kind of competency of FlexEye is around collaborative ecosystem development, and that's what I'm going to be spending most of my 15 minutes on. In terms of FlexEye is the lead for Hypercat. So can I just have a quick show of hands who's heard of Hypercat? Okay, quite a few of you. So again, time box, so in a minute I'll try and explain how Hypercat came about. FlexEye was asked to do a project with the University of Surrey to do an IoT demonstrator, which it did, and that involved the Guildford Borough Council as well. And that spawned an intense desire to see interoperability in the IoT space, whereby devices can talk to applications, and that, we can develop this kind of plug-and-play ecosystem between hardware and software. And that's how HyperCat came about. And that's the tie-in to the cats. That wasn't meant to happen. I didn't know it's bi-directional. There we go. Okay. So what is HyperCat and how did it come about? It's a TSB-funded initiative. TSB is now Innovate UK, and they put in about £6 million into developing this interoperability standard for IoT, which is currently progressing with the BSI through what they call a publicly available specification. So that will ultimately end up as a BS standard and hopefully as an ISO standard as well. And as you can only imagine, it's up against quite a few different standards, particularly originating from the USA. For the technology-minded, it's an open, lightweight, JSON-based hypermedia catalog, hence HyperCat, format for exposing URIs. Or for us, it's just a simple way of encouraging plug and play, such that you can switch out vendors, switch out sensors, switch out actuators as you go forward, rather than being locked into one particular vendor. So in the real world, we have real things. Here I show a couple of examples. There's a bus and there's a building. The devices, whether they're sensors or actuators, connect that analog real world to the digital world. And that's a two-way communication. Often we talk about sensors and we forget about actuators, but we're strong proponents of having that full feedback loop. And then in turn, you have the apps being built upon that base, and then the apps obviously get exposed to the clients, whether it's a mobile client or some other clients. But what typically happens is, just like in any other technology, people do things in different ways and systems end up not being able to talk to one another. And that creates silos, and we think that's very dangerous in IoT. So HyperCat is all about breaking down those barriers, breaking down those silos, and sharing data and sharing information between devices and between applications. There we go. And as I alluded to earlier, that's a good thing for everybody. It's good for the buyers. It's good for the suppliers too, to encourage that open ecosystem. And that's something that we were talking about yesterday. I see some familiar faces here. In terms of FlexEye launched HyperCat City at the House of Lords, and the initiative there is to help drive the collaborative market development exercise, if you will, around the use of IoT in the smart city space. And here are some of the partners. So again, little old FlexEye, Karen talked about large companies working with small companies towards a common cause. FlexEye is about 35 people, yet we've been able to encourage about 300 companies to participate in HyperCat, which I think is great for UK industry. FlexEye, as I alluded to earlier, is a technology company. So a couple of minutes on our technology. It's a product called iHub. And it's a software as a solution. It's a software as a service solution for building IoT applications. And what makes it somewhat unique is the fact that it requires no development whatsoever by the end user. So we're targeting the business user and encouraging them to build applications, rather than historically it's been developers who build those end user applications. And we work in a number of different sectors, but primarily we're focused on the smart city space. One of the things that makes FlexEye somewhat unique is the fact that we represent that real world in the digital world. So our software enables us or our customers to model those real world assets, whether they're buildings, whether they're devices, or even people. And they all have their counterparts in a digital world. And that enables us to define some business logic or business rules around those digital entities in our models. So all of our digital models and the entities within them understand their purpose, their stakeholders, their context, and their interrelationships as well. And what that enables us to do is then enable those digital entities to receive observations from sensors and empower them to be able to make decisions and then to take action, which is where the actuators come in, which I spoke to earlier. And one of the things, again, that we're trying to promote is the concept that it's going to take a long time for our customers and probably your customers to move towards having digital sensors and actuators. And let's not forget the human, who is an uber sensor actuator in their own right. So we've been working hard to build a mobile client whereby a human being can make observations about what's happening and then close the loop by acting as an actuator. One of the things we did a couple of months ago is to build a digital model for Canary Wharf. That was for a Hypercat event back in, I think it was October. So we took the entire Canary Wharf development, created a digital model, started off at the high level, so it's a block plan, a street plan, all of the buildings, and then we drove down into One Canada Square and modeled the entire building, all of its floors, all of its rooms, all of its access points, right down to individual devices. And then went one step further, and working with Ian and company at Eurotech, we were able to show how easy it was to onboard a Hypercat enabled sensor. So the whole process took about 30 seconds, whereby our software was able to auto-detect the presence of a Eurotech sensor, start to get a feed of information from that sensor around a whole array of data, not the least of all was the carbon dioxide level. And it was quite amazing to see the results because we had some 250 people in that room and the values went sky high. And it was quite interesting prior to that event because the temperature in the room was extraordinary as people were coming into the room and there was no actuation. So you'd think that a building, development like Canary Wharf would be quite sophisticated, but actually it wasn't. And we had to go out to the reception to ask them to turn down the temperature. What was also interesting at the end of this, having onboarded the sensor, we weren't able to close the loop and have access to the building management system within Canary Wharf, so we couldn't close that loop. So I think there was all sorts of lessons learned, but back to bare basics, being able to onboard a sensor in a matter of seconds really shows the power of Hypercat. Just last but not least, how long have I got? 5 minutes, perfect. I just moved back from the States, and one of my heroes is Guy Kawasaki that helped set up the third-party developer program for Apple all those years ago. And he had this concept called jumping curves, which talks about disruption. And there are a couple of ideas or a couple of examples historically around disruptive innovation, one of which is the ice industry, where many decades ago, it started off with people harvesting ice at the source, which would be frozen lakes in North America. Then that moved maybe 2 decades later to centralized ice farming actually within a city so that the point of origin of the ice was much closer to the businesses and the residents within the city. And then there was a further leap to having refrigeration and ice within the home. You could argue the fourth step was being able to press a button on the front of a refrigerator and for ice to come through. Why I bring that up is that we believe that we're on the cusp of that sort of disruptive innovation within smart cities, where in the past we've evolved into, let's call it a managed city, and what we're interested in as FlexEye and leveraging Hypercat 2 is to enable that transition to being truly smart. And on that note, we think that the distinction is with managed cities, you have sensors, you have actuators somewhat, but what makes it truly smart is by helping that city to act on its own. So it needs, the city and all of its constituent parts, which is, somewhat a complex system, needs to understand its purpose. Why is it there? Who is it serving? Who are its stakeholders? What are its goals? How is it doing towards those goals, which is where the performance element comes in? What are the constraints by which it must operate? And then to use that information to effectively optimize itself to try and predict what's going to happen in the future and to learn from that. So that's our vision for helping the industry to transition from being smart to from being managed to being truly smart. I came in under time, which is quite amazing.
Right, so who have we got next? Yeah, Leonard, are you?
So I'm Leonard Carey from Arkiva. I just got to say, the last time I had one of these in my hand was karaoke. Now, I don't know if I'm a West Country boy, so I'm going to say it was karaoke at Skittles. Anyone know about Skittles? It's not. You don't ask. Oh, because someone must know about Skittles. It's not 10-pin bowling, but you're trying to hit the gaps. But anyway, so I'm here today to talk about Arkiva, who we are, very quickly, but also about this bold statement about unlocking the promise of the Internet of Things. But also, in the vein of the other speakers before me, it's all about collaboration. And although we're not here, Arkiva aren't here to say we have the only answer, what we think we've done, is we've unlocked a blocking point to help others come along and develop the things that have been very difficult in the past to develop in mass numbers. Just a little bit about Arkiva. It's one of those brands where not many people have heard about it. But you know, we keep saying it in the office. If you switched on your television today, if you switched on your mobile, there was some Arkiva services behind it. Okay. So the history of Arkiva, a lot of it's been in broadcast TV. The BBC, there's a whole roll call of big achievements, but it goes back to 1922. I was up in Leeds the other day in Huddersfield, and we've got the huge tower up there. I think it's one of the tallest structures in Europe. So we operate a huge network. But it's not just TV broadcasting and radio, but it's also satellite, it's Wi-Fi as well. And latterly, it's about what can we do, taking all that expertise to deliver a network that is for, in one case, it's for 10 million homes in the north of England, and it's a very highly secure network for smart metering, but also, most recently, delivering the Sigfox network and rolling that out nationally, starting in 10 cities in the UK. I'm just going to pause there, because one thing I've noticed, I've go around some of the cities in the UK and talk about we've just rolled out this network. They say, really? Have you? Haven't heard about that. What's that all about? You know, they think that we're looking for money to roll it out. But no, we've made the decision to unlock that promise and deliver a network that enables developers, software developers and hardware developers, solution providers to come up with new solutions around very small messages, lots of small objects, sensing things, bringing data back, and helping organizations make decisions based on those small messages. And we think that it's going to add a lot of value to the whole debate around smart cities, smart health, even having a Fitbit for a dog. There is actually a Fitbit for a dog. I think they call it Whistle. If you have a look on the internet, you'll find it. We announced the network, our rollout plan, back in December, and you know we it was quite light touch, but we talked about how suddenly bins and parking spaces, weirs, your soap dispenser can now start talking to the network, start talking to a central location cost effectively. I think in the past there have been many different types of technology out there that can do the same thing. What we've now done is said, let's put a wide area network in place that really can make it very cost effective to have a very small radio using the 868 unlicensed band, which makes all the components quite inexpensive, but also opens up a lot of opportunity for people to develop things which, you know, I certainly don't have the brain power to even think about what could be done. You know, this whole Fitbit for dogs, where did that come from? But it's using that sort of capability. Just a little bit about the Sigfox network. We actually have a demonstration, and Gavin, he'll be able to show you a bit about some of the devices, but also how it works on the network as well, and how those messages get transmitted, and how long range it is as well. Because although it's using the unlicensed band, we've deliberately used technology that, rather than taking it from a short range radio, 5 minutes, short range radio, it takes it to a longer range. So we don't need so many antenna base stations to cover a city or cover the UK. You know, the architecture is very straightforward. It is about taking those devices, taking our expertise in radio planning, in using our assets around antennas, our masts and towers, and using the land and the sites that we already have to develop the network and make it available to everybody. Taking it back to a cloud infrastructure and making that data available to the organization, to the developers, the solution providers to do what they want to do with it. We're not going to process that data. Let's make it simple. Let's make it that whoever has the, who's clever enough to use that data, and I know FlexEye, taking that data and visualizing it, making it richer, that's something that all you guys in this room are able to do. What we want to do is make sure you've got every opportunity to get that data from those sensors and have hundreds of thousands of them if you really need to. Okay. So just to recap a few things, it's part of our rollout strategy is to start with the 10 largest cities. You'll notice that Reading's not on there. Okay, there's a deliberate reason for that. But Reading, we do want to go to towns and boroughs and cities other than the 10 and start building up this ecosystem, start building up this awareness, but start building up this idea of, yeah, even if you're a small to medium-sized enterprise, how can you start using the network very quickly, using all the components to build sensors and to build solutions that have commercial sense. And I think, Karen, you were saying about getting some of those ideas and taking them all the way. 3 minutes now. So it's about hopefully enabling businesses to develop solutions which in the past have been quite challenging to develop. And this is the last slide. Okay. So this is our beginnings of our ecosystem, but it's growing all the time. And the reason why it's growing is that we are engaging in a lot of hackathons with universities, with cities, partner days as well, to really encourage this idea of, you've got the network, here are the components, build something, use it, test it, see where the value is, and see how far you can take it. So the ecosystem's growing all the time, and hopefully tonight we'll speak to some of you and help you along the way, and you could perhaps help us as well. So this is about collaboration. We have unlocked that part of that promise, which is really, I think, about 90% of where IoT is going to be. There's small messages, lots of objects, bringing lots of messages back so you can use that crowd-sourced information to get better insight. I think I'm under time. That's great. Thank you very much.
Cheers. Right. Tim. Where's Tim? Tim? So, Tim Bailey is from the Department of Energy and Climate Change. That is the one to advance. That one there.
This one there, okay.
Yeah, yeah.
Thank you very much. Yes, hello. So I'm Tim Bailey from the Department for Energy and Climate Change. I work in the smart metering team, and I've been there for about 5 years now. So I guess that gives an idea of how long this has been developing, and it's quite good to see now that finally there are smart meters meeting our specifications being installed. And today I'm here to talk a bit about the data that will be available from smart meters. And how companies and consumers will be able to access that data and the possible applications for that data. So I'll start off just by giving an idea of the scale of the program. It is a huge program, and it's going to involve visits to all homes in Great Britain. 53 million meters will be installed by the end of 2020, so that's around 29 million electricity meters, and the rest gas meters, because not everyone is on the gas grid. The other key points that it's always been important in developing the policy for the rollout that consumers. So there are supplier benefits in terms of an end to estimated billing, not having to send around meter readers. However, a key part of the business case is that consumers will be able to save energy, and to enable that, we need to ensure that consumers can access their data and can also allow companies to access their data to provide them services. So that's a key part of our policy. I'll explain the two ways in which that can be done in the next slides. However, one of the ways is by connecting gateways which can receive data locally within the home and then forward data, as we've been talking about, to the cloud, where it can be analysed and used to provide services. And the important point again is that the energy supplier is not involved in either of those routes to data. So we've developed a system where customers will be able to connect devices without the involvement of their energy supplier. Customers will be able to give permission for third-party companies to access data from their meters without the involvement of the energy supplier, which I think in other rollouts, the energy supplier has always been involved, and that hinders the development of competition in the energy services market. Because essentially what we're trying to do is create this level playing field between existing energy suppliers who have the existing relationships with customers. However, they're not necessarily very developed in their thinking on providing energy services and energy efficiency advice, and new companies who want to enter the market and provide those services. So that's the key point, that if you want to get data from a smart meter to provide services, you have to go through the same steps if you're an energy supplier as you do if you're another user wanting to provide innovative new services. It's not going to work now. Or is it that way? There you go. So this is just an overview of the end-to-end system. So the equipment that everyone will get in their home will consist of a smart electricity meter, a smart gas meter, and there'll be a communications hub, which will have the WAN module, the wide area network module, and everyone will be offered an in-home display which displays energy information, a mandated set of energy information. And then in addition, people will be able to connect what we've called a consumer access device to their network, which will be able to stream data from their system in the home. Then we have what's known as a data and communications company, which sits in between the equipment in the home and the parties who want to. So either configure the meters. So when I say configure the meters, that may be to set a new tariff on a meter, or it may be to retrieve billing data from a meter, or may be to retrieve half-hourly data from a meter. Or to read information. So you can either configure parameters on a meter, or you can read data from a meter. And Smart DCC consists of the holding company, which is Capita, and below that there's a data services provider, which is CGI, and then there are a communication services provider for the wide area network, which is Arqiva in the north, so Scotland and the north of England, and Telefonica in the central and southern regions. So that provides a wide area network. To give an example, a service which is offered by the DCC so these are the DCC users who can send messages to meters to configure or read data from meters. And an example of that is a update tariff. So any energy supplier can send a message. One of the services offered by DCC is update tariff. So an energy supplier can send a message to update the tariff, for example, to switch to a time of use tariff or switch to a prepayment tariff. And that will be sent down to the meter via the wide area network provided by Arqiva or Telefonica down to the communications hub, where it will be updated on the meter, and then there will be a response will come back. And so the key services which are available to other DCC users, so they'll be available to suppliers and other users, are the read profile data, which is read the half-hourly consumption data. All meters will store 13 months of half-hourly consumption data, and all meters will store all of the tariff information. So that's another key point, that the information is stored on the meter. There's no central storage of data. So whereas in other countries you have a big central database of consumption data, here all the information is stored on the meter, and the consumer will give their permission for parties to access their data. So that service of reading the data is available to any DCC user, so energy suppliers or other parties with the permission of the consumer. And in terms of what data will be available, so the electricity meter and the gas meter, or effectively the communications hub, will store all of the tariff information. So if you're on a time of use tariff, at the moment most people are on single rate tariffs, but one of the good things about smart meters is that they support time of use tariffs, which means that rather than needing a meter exchange to switch to a time of use tariff, suppliers will be able to send remote updates to switch you onto those kind of tariffs immediately, which we expect will lead to a great development in time of use tariffs. And also all the 13 months of half-hourly consumption data, so how much electricity and gas you consumed in every half-hour period for the last 13 months. And 2 years of daily consumption data, and 3 months of export data. So all meters measure import and export if you have microgeneration. And so all of that data is available either via the wide area network, by one of the service requests that I referred to in the previous slide, or by connecting a consumer access device to your home area network within your home. And I'll go through those two routes in the next 2 slides. In addition, so all of that data is available by either route. In addition, if you connect a CAD, you're able to receive 10-second updates of the current price, the instantaneous active power, so the kilowatt consumption, and the register reads, and prepayment information. So obviously that allows another level of service, because if you're receiving 10-second updates, you can do things like send alerts, perform more accurate monitoring, for example. So remote access via DCC. This is I don't know if everyone can see this. It's quite small. But the steps are, so a consumer will provide their address and their consent to the energy supplier or other DCC user, so any party who has signed up to use DCC services. That user will then verify the details, send a service request down to the meter saying, please retrieve the data, half-hourly data for this metering point for the last, and then you can specify the time period for which you want the data. That is encrypted at the meter. It's returned via DCC back to the user where it can be decrypted and then used to provide a service to a consumer. So, for example, you could have a switching site who could have an app which said I can tell you what the cheapest tariff is, including time of use tariffs. They can retrieve data from the meter and then tell the consumer what the cheapest tariff is. And you can do that either on an ad hoc basis, or you can set schedules at DCC. So you can say once a month, please go and read the data from the meter, and then once a month you can give an update to the consumer on whether they're on the cheapest tariff, whether they should switch. So that's a remote access route. And So I think that's one possible application. However, you would have to explain to the consumer what their data is being used for. But if the consumer signs up and wants to sell their data to make money, then they could do so. So the other route to data is by connecting a consumer access device. Any device with a Zigbee SEP. So Zigbee is a home area networking standard which has been chosen for the GB rollout. So it's a standard that's used to exchange data between the gas meter, the electricity meter, and the IHG. And in addition, any device with a Zigbee SEP 1.2 interface, so that's a version of the Zigbee standard. So any device which has that interface and access to the Zigbee features defined. So we've defined a set of features from the Zigbee Set 1.2 standard for the purposes of our rollout. And so any device can connect to the network and request all that data, and that is all of the consumption tariff information held on the meter. So beyond that, we haven't specified what a CAD has to be. So it could be anything with that interface, which means it could be an in-home display, it could be an energy orb, it could be a gateway. So it could be an energy-only gateway, which is only streaming energy data, but it could be a gateway which is doing lots of other things, from multimedia, music, etc. But by adding support for Zigbee SEP, you can also stream the energy data from a smart meter. It could be a smart appliance. So there are two routes really. You can either have a gateway which is forwarding information to smart appliances, potentially via other protocols, or the smart appliance, if it has a Zigbee SEP interface, could connect directly to the smart meter and get information. Smart energy hubs or gateways, laptop dongles, thermostats, so smart heating systems. If you have smart heating hub, that could also receive data as a question, I think. Or 2 minutes. Or a router, so you could turn a router into a gateway. It would sell the ability to. So the consumer has to give their consent to connect to any device. So here you can see that the consumer will provide their address, the ID of the CAD, and consent to the user. Then the user will forward a message to the communications hub saying when the CAD with this ID appears on the network, allow it to join, because it's allowed to join. Yeah. So then when the CAD appears on the network, it's recognized as being allowed to join. It can join. Then it will start to receive data. The important point is once it's connected, it won't use the Archiva or the Telefonica route to get data back. So it would, so today you see CADs, consumer access devices, which are plugged into the back of Wi-Fi routers, which then stream data to the cloud. So you can see it on your smartphone. It can be used for analysis. So those devices exist today. In the future, you can imagine that will be integrated into more complex hubs, which are also doing other things. So there we go. That's right.
So there's going to be lots of questions. You'll be around in the breaks.
Yeah, of course, yeah.
And the